Okay, geometry students, today we're going to continue our review for the spring exam. I know that taking notes over and over is pretty boring, but I have tried all year long to keep the notes within reason, and when I have not kept the notes within reason, I have then tried to not give you homework until the next day. So I know you guys are not used to taking notes for 45 minutes in a class period, but it's what we have to do to make sure you guys are ready for this exam. So grab your notebooks, pens, pencils, calculators, and let's review, okay? We're going to pick up with lesson 8.4 today. If you want to make note of that in your notes, which I would encourage you to do, and if you want to write the date down, you can do that also. This is the date that we covered lesson 8.4. Now, in this lesson, we started talking about similar triangles, okay? Similar triangles. Now remember, if two triangles are similar, then the following statements are true. Because we know this, because anytime two figures are similar, then these following statements are true. So that also would include triangles. So remember, if two figures or if two triangles are similar, these statements are true. Copy this in your notes, please. The angles will be congruent, period. If two figures or two triangles are similar, then the angles will be congruent, period. Secondly, the corresponding sides will be proportional. So please copy this down. I'll give you just a minute to do that. Or actually a couple seconds to do that. The angles will be congruent if two triangles are similar, and the corresponding sides will be proportional. Okay? Alright, now, if you were to draw a triangle with angles that measure 20, 50, and 110 degrees, and then draw a non-congruent triangle with the same angle measurement, the two triangles would be similar. Okay? Let me demonstrate, alright? I would encourage you to copy this in your notes, okay? Let's draw an angle that's about 50 degrees. So 50 degrees would look about like that, we'll say, okay? And then we're going to draw another angle that's 20 degrees. And of course 20 degrees would come down. 20 degrees would be about that much, approximately, something like that. And so we're going to assume the leftover angle is 110 degrees. Alright? Did not mean to do that. It's not what I wanted to do. And that's not what I want to do. Okay, so I'm going to go ahead and put 20 degrees here. Actually, I'm going to copy this first. And now, I'm going to go ahead and put 20 degrees in here. Or excuse me, 50 degrees here. 20 degrees here. And 110 degrees here. Now, I'm going to take that same triangle and stretch it out and make it a little bigger, but keep the angles the same, okay? So this is still 50 degrees. I would copy that in your notes if I were you. This is 20 and this is 110. When we do that, these two triangles will, period, always be similar. If the three angles in a triangle are congruent to the three angles in another triangle, notice the two triangles are not necessarily congruent. Sometimes they are, sometimes they're not, but they're always similar if the three angles in one triangle are congruent to three angles in another, okay? And so that's kind of a springboard that leads us into postulate 20, okay? So here it is now. I would encourage you to write this in your notes, or at least make note in your notes to study this, okay, to know this. Not because it's going to be a fill in the blanks, it won't be, but because you need to understand what this principle teaches. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar, okay? I would write that in your notes, or make note somewhere in your notes where this can be found in your notes, okay? You need to understand postulate 20 and be able to apply you can. It's up to you. If this angle here is 40, and this angle here is 90, this angle here is 40, and this angle here is 90, I know immediately that these two triangles are similar because of the angle similarity postulate. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. Because, guys, we know that the third angle has to be congruent also, because 90 plus 40 is 130. This has to be 50. 90 plus 40 is 130. This has to be 50. So if two angles in a triangle are congruent to two angles in another triangle, then we know for sure the third angle has to be congruent. So if two angles in one triangle are congruent to two angles in another triangle, then we know the two triangles are similar. So with that in mind, copy down this problem, please. I will wait. I will wait a couple seconds while you copy down this problem, please. Copy this in your notes, then go ahead and work ahead if you want to, or you can watch me. Two triangles are both isosceles. The vertex angle of these two triangles is the same. Its measure is 52. Are these two triangles similar? Give us a little room to work here. Two triangles are both isosceles. The vertex angle of both of these triangles is the same. It's 52 degrees. Are these triangles similar? Well, let's see. Here we go. Let's draw an isosceles triangle here and a bigger isosceles triangle here. Alright? And we're going to say this vertex angle is 52. And this vertex angle is 52. Now, at first glance at these two triangles, I'm going to say no. We do not know for sure that they're similar because all that we have is one angle in one triangle congruent to one angle in another. Okay, that's the first thing that pops out. But hold on, let's take a second. We do know that we have isosceles triangles. That means this side is congruent to this side, and this side is congruent to this side. By the way, I know which two sides are congruent to which two sides because they called this the vertex angle. Okay, and remember, the two angles down here that are congruent, that connect the two sides that are congruent, are called base angles. This is your vertex angle, so I know that the two sides that are congruent are these two sides here and these two sides here. Now, remember what you've learned this year. If two sides of a triangle are congruent, then that means their opposite angles are congruent. So these two angles are congruent to each other. You probably say, well, what's the big deal? Well, let's see. If I take 180 and subtract 52, I'm going to get 128. Okay? So these two angles added together have to equal 128. Divide that by 2 because these two angles are congruent, and you get 64 and 64. Alright? Now, guys, you can probably see what's happening already. The same thing's going to happen over here. If this side here is congruent to this side here, then their opposite angles are congruent. So this angle here is congruent to this angle here. So if I take 180, subtract 52 from it, I get 128. Divide that by 2, I get 64 degrees. 64 degrees, yes. These two triangles are definitely similar because I know that three angles here are congruent to three angles over here. Or you could say two angles of one triangle are congruent to two angles of another triangle. Or you could say these two angles are congruent to these two. Or you could say these two angles here are congruent to these two angles here. Whatever route you go, we definitely have similar triangles, okay? Because it only takes two angles of one triangle being congruent to two angles in another triangle. Alright? Okay, moving on. Now, are these two triangles similar? I'll give you just a second. Please copy this in your notes. Are these two triangles similar? Please copy this in your notes. one angle in one triangle congruent to one angle in another triangle. Okay, but so I don't know for sure if they're similar, but I know the three angles here have to add up to 180. So if I add these two together, I get 80. So I know this angle here has to be 100. Well, look at that, I'm finished. Do you see these two angles here? They're congruent to these two angles here. Anytime you have two angles in one triangle congruent to two angles in another triangle, you know immediately these two triangles are congruent. No, not congruent. They might be congruent, we don't know for sure. What we do know for sure is these two triangles are similar. Okay? Alright, let's continue on. Now, we're not going to do a proof, so relax. In fact, you don't even have to watch, you don't have to take notes on this. I do want you to watch it, but you don't have to take notes on it. Now watch, guys, look. This would be a fair problem on an upcoming exam. If to give you a proof like this, look, if I want to quickly prove that this triangle here is similar to this triangle here, watch how easy it is. We know that when two lines intersect, vertical angles are congruent, so I can easily state this angle here is congruent to this angle here. Now, once I state that, I can also state this angle here is congruent to this angle here, because if two sides are congruent, their opposite angles are congruent, and I can easily state that this angle here is congruent to this angle here, because if two sides of a triangle are congruent, their opposite angles are congruent. And then from there, just like we did back here, when we knew that we had one congruent angle here, and then opposite sides congruent, just like that there, we can very easily state that these two triangles are similar by the angle postulate, okay? And how I would go about doing that probably would be to I would probably list out, students, something like we call this angle 1, 2, 3, call this angle 4, 5, 6. I'll probably say 1 plus 2 plus 3 equals 180. Angle 4 plus 5 plus 6 equals 180. You can just watch this. You don't need to take notes. And then bring these over here so they become negative. Bring angles 5 and 6 over, they become negative. And then, of course, you can substitute 1 in for 4 right here. So you can all, because 1 and 4 are congruent, we already stated that. And then from there, what you could do is state these two angles are congruent. These two angles are congruent, and prove that you're subtracting the same number from 180. And you can easily prove these angles are congruent. So I'm not going to go into huge detail, but I'm just saying, be ready for some proofs on the exam, okay, guys? Because they could be on there, alright? So understand, first of all, the angle postulate. When two angles in one triangle are congruent to two angles in another triangle, the two angles are congruent. Or the two triangles are similar. Okay, lesson 8.5 review. January 27th, please make note in your notes that we're transitioning now over to lesson 8.5, okay? Please make note of that in your notes. And here we go. In this lesson, we learned two ways to prove that triangles are similar, okay? We learned two ways to prove that triangles are similar. Now, we learned one way in the last lesson, and that was the angle method, or the angle postulate. Alright, here are the two ways, and I want you to write these in your notes. If three sides of one triangle are congruent to three sides of another triangle, then we know that if three sides of one triangle are proportional to three sides of another triangle, then the two triangles are similar. Okay, I apologize for not saying that correctly the first time. If three sides of one triangle are proportional to three sides of another triangle, then the two triangles are similar. Okay, then we have the side angle side theorem. If two sides of one triangle are proportional proportional, I'll put ditto marks here, if two sides of one triangle are proportional to two sides of another triangle, and their included angles are congruent, then the two triangles are proportional, or excuse me, are similar. Now, let me go over these a little better for you so you can see some pictures, okay? I would definitely write down these examples if I were you. I think these are very, very important to write down, so please copy these down. Let's say I have a triangle here that has a length of 2, 3, and I don't know, 4, okay? And this triangle over here has lengths of, this is a pretty simple problem, 4, 6, and 8. Do you see how the three sides here are proportional to the three sides over here? Watch carefully. I can say, well, 2 over 4 equals 3 over 6 equals 4 over 8. And if you reduce all those fractions, you get 1 half equals 1 half equals 1 half. So after you simplify each fraction, if all three fractions are the same, then you know the two triangles are similar. So that's what this theorem is saying. If three sides of one triangle are proportional to three sides of another triangle, then the two triangles are similar. Okay? Alright, let me give you an example of side angle side. Please copy this down. Let's say we have a triangle here, and this angle here is 85 degrees. This side here is 4, and this side here is 6, okay? Then we have a little bigger triangle over here. We'll go a little smaller triangle. Here's a little smaller triangle over here. We'll say this is 85 degrees right here, alright? And we'll call this 2, and we'll call this 3. Now notice I have a side angle side that I'm looking at, okay? And I'm comparing that to a side angle side. Now first of all, the included angle has to be congruent. Is that the case? Yes, it is. This angle here is congruent to this angle here. So far so good. Now the two sides have to be proportional to the two sides over here. So 4 over 2 equals 6 over 3. Let's see if that's true. Reduce both of these fractions and you get 2 over 1 equals 2 over 1. So look at that. Are the two sides here in this triangle proportional to the two sides over here? Yes, they are. And is the included angle between those two sides congruent to the included angle over here between these two sides? Yes, it is. So we can state that these two triangles are definitely what? Similar by the side angle side proportional theorem. Okay? Alright, now let this sink in. Make sure you're taking really good notes. Alright, let's continue on. And actually, students, before I continue on, make sure on the test you're able to prove. Now, do I mean prove like a proof like this here? Maybe. I'll probably put some proofs on your exam. But right now, when I say be able to prove, I'm not talking about 2-column proofs. I'm just saying be able to look at triangles and tell me whether or not they're similar. Yes, they are. No, they're not. And if they are, tell me why. Tell me how you know that. Please be able to do that, okay? That's really, really, really important. Alright, let's continue on. Now, I need to go over reviewing how to write statements of proportionality. Okay, students? So please watch carefully as I review this with you. Take some really good notes. You definitely need to know how to do this, alright? Let's say this triangle here is similar to this triangle here, alright? Let's call it triangle A, B, C, and triangle D, E, F. Now I want your letters to be just like mine in the same order, so I'm going to pause a second while you copy this down. Okay. Now I want to do something a little interesting here to throw a curveball at you. You're thinking this angle's congruent to this angle. I'm going to switch it up. I'm going to say this angle's congruent to this angle. This angle here is congruent to this angle here. And this angle here is congruent to this angle here. So please mark that on your notes, okay? Now, I want you to write a statement of proportionality. Alright? Now we can do that pretty simply by simply doing this. Triangle A, B, C, alright, is similar to triangle. Now I put A first, 1 mark, so D comes first over here. Next is B with 2 marks, so E would come next over here. Last was C. C has 3 marks, so the angle with 3 marks over here is going to be F. Now we're not finished. If you think this is a statement of proportionality, you are totally 100% incorrect, okay? This is called a similarity statement. So why don't you make note of that in your notes, please? So if on the test I ask you to write a similarity statement, this is what you would do. Just make sure you line up corresponding or congruent angles with congruent angles. Got it? This is called a similarity statement. So Mr. Earhart, what is a statement of proportionality? Well, I'm glad that you asked. The reason we wrote this first is, oh my goodness, it makes writing the statement of proportionality so much easier. What are your first 2 letters here? A, B. So they correspond with DE. So you put AB over DE equals, now what's your next 2 letters? BC. BC would go with EF equals, and then AC would correspond with DF. Now I'm telling you, you are more than welcome to skip this step right here if you want to. But I am telling you, that step right there made it so much easier to write my statement of proportionality. And so be ready on the exam coming up. Know how to write a similarity statement, and also know how to write a statement of proportionality. Okay? And of course, the similarity statement will help you be able to do that. Alright, let's continue on. Here we go. Let's move on to lesson 8.6, and we'll be finished with chapters 7 and 8 in our review, okay? Lesson 8.6, if you want to write down the date, we covered this material on January 28th. Seems like a long time ago, doesn't it, guys? January 28th. In this lesson, we learned 4 different theorems about proportions and triangles. So we're going to take our time and go over this, and you need to know this information for your test and be able to apply it to problems. Okay? Alright, here's the first one. Now you don't need to copy this down unless you want to. I'll leave that up to you. But I'm telling you, you know what? We're taking notes, okay? Please copy this in your notes. I'm going to pause a second. I know the supervising teacher is roaming the room looking. Go ahead and copy this in your notes, please. You do not have to know it for your test word for word. We're not going to have fill in the blanks, but you need to be familiar with this and know how to apply that, okay? If I'll do some problems, which we're going to do in a second. If a line is parallel, to one side of a triangle intersects the other 2 sides, then it divides those 2 sides proportionally. Alright? And I will explain this in just a second. I'll give you a couple more seconds to copy this down. Okay, here we go. Here's what it's saying, students. I'm not sure if I have. No, I don't. Okay. Here's what it's saying. If I have a triangle like this, please draw this triangle in your notes. If I have a triangle like this, and then I draw a side, if there is a line drawn that's parallel to this third side. So I could draw a line like this. Okay? As long as this line here is parallel to this side here, then it divides these two segments up here proportional to these two segments over here. Let me go over that again. If you have a triangle and there's a line drawn connecting two sides of the triangle, it could be these two sides here, guys. It could be drawn from here to here. As long as that line right there is what? Parallel to this side over here, then these two segments and these two segments are proportional. Okay? So that's what this theorem is saying. If a line is drawn connecting two sides of a triangle and parallel to the third side, then it divides the two sides up. By the way, this word should be proportionally. I'm not sure why I put proportionality. Proportionally. I hope that's how you spell it. I think it is. If not, oh well, proportionally. But anyways, moving on. This is what the theorem is teaching, okay? Now, let's look at an example and go over this, okay? So look, if you're given a problem like this in the final exam, you should be able to solve for x. Copy this in your notes, please. Copy this down. I'll give you a second to do that. Please copy this down. Now, here's what it's saying. I have a triangle right here, as you can obviously see, and inside that triangle, a line has been drawn that connects two sides of the triangle, or intersects two sides of the triangle, and it's parallel to this side here. So that means these two segments here, 5 and 2, are proportional to these two segments over here. So you might say, oh, Mr. Aaron, how do you set up your proportions? That's really not easy to see. Well, I'm glad you asked, and I will show that to you right now. There's many ways you can set up your proportions, okay? Watch this carefully. Many ways. You can first of all say 5 over 2 equals 6 over x. That is totally awesome. That works fine. No problem there. 5 over 2 equals 6 over x. Or you could also say as 5 changes to 6, as 5 changes to 6, 2 changes to x. And that would also work, okay? So I'm gonna prove that to you real quick. Let's solve this proportion right here. 5 times x is 5x. 2 times 6 is 12. Divide both sides by 5, and x equals 2 and 2/5, or 2.4. Same thing over here. 6 times 2 is 12. 5 times x is 5x. Divide both sides by 5, and you will get 2 and 2/5, or 2.4. Alright? So, anytime you have a triangle, there's a line drawn that intersects two sides, and it's parallel to the third side, then these two segments here are proportional to these two segments over here. Moving on. Now, theorem 8.5, the triangle proportionality converse. If a line divides two sides of a triangle proportionally, that is parallel to the third side. Students, this is just the converse of the other theorem. Please listen to this carefully. Watch this. In fact, I want to do this. This. And I would like to, excuse me for yawning, grab this and pull this over here so you can see them right underneath each other. Alright? Okay, students, now look at this. If a line is parallel, then it divides the two sides proportionally. Look at this. If a line divides the two sides proportionally, then it's parallel. This is the complete converse of the other. So, if you have a triangle, now listen, just kind of watch, and you know you have a parallel line right here, then you know this segment here, you know these two segments here, 1, 2, are proportional to these two sides here. We just learned that. However, now we're learning this. If these two sides here, this is the length of 1, this is the length of 2. Let's say this is a length of, we'll just say it's, a 2, this is a length of 4. As you can see, the 1 increased by a multiple of 2, and the 2 increased by a multiple of 2. In other words, we have 1/2 equals 2 over 4. That's a true statement. Or we could say, well, I'll just leave it at that for now, but the point is if I have two segments here proportional to two segments over here, then I know this side is what? Parallel to this side here. Okay? Let's see if we can't kind of make this a little more clear in a problem, okay? Copy this in your notes, please. Copy this in your notes. Copy this in your notes too. I'll give you a second to do that. Our lines B, D, and CE parallel. Copy that down, and then copy down this problem right here. Our lines B, D, and CE parallel. Are they parallel? Give you a couple more seconds to copy this down, please. I want this in your notes. See, the tough thing about geometry, guys, in Algebra 1 or 2, and I know I've taught those for years, taught pre-calculus for years, the thing that you can do in pre-cal, Algebra 1 and Algebra 2 is tell the students, we're going to have graphing quadratic equations, graphing quadratic inequalities, solving polynomial functions, second degree, third degree, fourth degree. You can tell the students the problems in geometry. I can tell you the principles, but I really can't tell you the problem because there's so many different ways to give you a problem that would make you use this theorem, and that's what makes this difficult, not necessarily to teach, but for you guys to study for your exam, okay? So you're really going to have to know these theorems and these principles I'm putting up here pretty well. Okay, is this line here parallel to this line here? Well, let's see. We've learned that, well, first of all, we've learned we can say 8 over 3 equals 6 over 4. Okay? Another way we can do this is we could say as 8 changes to 6, 3 changes to 4. There. Well, let's see if these and by the way, you don't have to do both of them. Let me say it again. You don't have to write both of these proportions. Just one of them is all you have to write. I'm just trying to show you both ways so you know you can do either one of these. Or, okay, well, let's reduce both of the fractions and see if we get the same fraction. 8 over 3 cannot be reduced. 6 over 4 reduced to 3/2. Are they identical fractions? Not at all. Not a bit. Same thing over here. Reduce 8 over 6, you get 4 over 3 equals, reduce this and you get 3/4. 4/3 is not equal to 3/4. So it didn't matter which way you go, this way or this way. You do not get out a true statement. So even though these two segments here look like they're parallel, they are not parallel. And I know that because this segment here and this segment here are not proportional to these two segments over here. So these two segments here are not parallel. Alright? Hope that makes sense. Let's look at another theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. If three parallel lines intersect two transversals, then they divide. And by the way, I would write this differently. I don't like how they've written it. I would say if three parallel lines are cut by two transversals, then the parallel lines divide the transversals proportionally. That's how I would say it, but either way is fine. We know we have three parallel lines, correct? So we know we have three parallel lines. 1, 2, and then 3. There's my three parallel lines, okay? If three parallel lines intersect two transversals, so here's one transversal, here's the other transversal right there. So copy that in your notes, please, okay? We'll call this line A, line B, line C, line D, and line E, okay? So quickly copy this down. And I would definitely copy this theorem in your notes too. I really would, guys. So you can study this. If three parallel lines, let's put the parallel symbols here, intersect two transversals, 1, 2, then they divide the transversals proportionally. Now here's what it means. Guys, just like in your triangle, when you had this line drawn, these two segments here were proportional to these two segments here, correct? Well, it's the same thing here. What they're saying is these two segments here on the transversal here and here will be proportional to these two segments over here. That's all they're saying. Okay, that's it. So, with that in mind, if I told you this was a 2 right here, and this was a 5, and this side over here was a 9, and I told you to find this length right here, x. Well, as soon as you see you have three parallel lines, 1, 2, 3, cut by two transversals, 1, 2, then you should remember this theorem right here. These two segments here are proportional to these two segments here. So I could say 2/5 equals x over 9. That's totally awesome. Or you could say as 2 changes to x, 5 changes to 9. Either way you'll get the same answer. 5 times x is 5x. 9 times 2 is 18. Divide both sides by 5 and you would get 18 over 5, or 3 3/5, or 3.6. Same thing over here. 5 times x is 5x. 2 times 9 is 18. Divide both sides by 5 and you will get 18 over 5, or 33 3/5, or 3.6. Okay, so make sure you understand this theorem. Three parallel lines cut by two transversals. They divide the transversals proportionally. Theorem 8.7. If a ray bisects an angle of a triangle, then it divides the opposite sides into segments whose lengths are proportional to the lengths of the other two sides. Okay, so let's copy this down. I'll be quiet for a couple seconds here. Write quickly if you would, please. And then we're going to talk about this. You need to know this for your exam. I'm just looking ahead for a second, okay? Because we're kind of running out of time here. Okay, here we go. Hopefully you've copied this down. Now, copy this in your notes. Let's apply this theorem. I want you to copy this triangle. And notice I have a ray right here drawn that bisects the angle. How do I know that? Because I've got an angle here congruent to an angle here. So I want you to draw this really big triangle. Not really big, but draw this triangle. And then bisect this angle right in half, okay? And be sure and label everything with the appropriate measurements, alright? Give you just a second to do this. We gotta hurry on, okay? Alright, here we go. Now look, here's what Theorem 8.7 says. Listen carefully, students. If I have a triangle, and I do, and one of the angles is bisected, now it says by a ray. I don't know why it says a ray. It can be a segment, a line, a ray, whatever. But if an angle is bisected like this, then here's what it does. It divides the opposite side, here's the opposite side over here, into segments whose lengths are proportional to the lengths of the other two sides. So you could say this. Now watch this carefully. I have a triangle, correct? Yes. I have a line that's bisecting or cutting this big angle right here, right in half. I know that because this angle here is congruent to this angle here. So when that happens, I can say 7 over 12 equals 6 over x. That would be totally awesome. Or you could say 12 over 7 equals x over 6. Okay? Either one of those two. And there's other ways actually to do that also. We could say as 7 changes to 12, 7 times x is 7x. 6 times 12 is 72. Divide both sides by 7 and you will get 10 and 2 sevenths, or 72 over 7. Same thing over here. 7 times x is 7x. 6 times 12 is 72. Divide both sides by 7 and you will get 10 and 2 sevenths, or 72 over 7. Alright, so understand this theorem, guys, what it means. Alright, let's continue on. We need to get to chapter 9 a little bit, so please copy down lesson 9.1 review. If you want to write down the date, feel free to. We cover this material on February 4th. In this lesson, we looked at right triangles a little more in-depthly than you were used to, okay? Now, you don't need to write that down, but that's what we did. Now, you do not need to write this down either. It's the Pythagorean Theorem. But you do need to know the Pythagorean Theorem. It's L squared, if you want to write that down, plus L squared equals A squared. If you don't need to write that down, that's totally fine. Alright? Well, that's not it at all. I apologize, guys. I'm totally wrong. Sorry. I'm ahead of myself. I have typed all these notes up, and I'm thinking of what's coming up here in the next couple lessons. Sorry. Okay. So, we're going to look at right angles a little more in-depthly. Now, here's theorem 9.1, and I do want you to write this down. So, please copy that in your notes. I'll give you just a minute. We're running a little short on time here. I'm trying to go a little faster, okay? And I know that we were supposed to get through all of chapter 9. That's not going to happen, and I'm not going to make you. I thought about making the video really long, like an hour and a half, and telling you to go home tonight and finish it. I'm not doing that. I'm keeping the review 45 to 50 minutes a day. If we don't finish it in class, you'll have no more than 5 to 8 minutes to finish at home, okay? So I'm really trying to not overload you guys. Okay, well, while I was rambling there, hopefully you copied this down. If the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. Okay, let's go over that again. If the altitude is drawn to the hypotenuse of a right triangle, then the two angles formed are similar to the original triangle and each other. So here we go. We're going to draw a right triangle. It has to be a right triangle, students, okay? So draw a right triangle. There it is. If the altitude is drawn to the hypotenuse, so we have to draw the altitude to the hypotenuse. Now, which side's the hypotenuse? Well, this side here is the hypotenuse. So we have to draw the altitude to the hypotenuse. So you don't draw it like this. Okay, it has to form a right angle. Don't forget that. So it has to come from the vertex and form a right angle. So I'm looking at it probably hitting maybe right about in the middle, approximately. It won't always hit in the middle. That's fine. There we go. So there's the altitude. Remember, an altitude always forms a right angle. So I'm going to label. I've got an A, a B, and a C. Now, please take some really good notes on this, students, okay? Well, I'm always looking ahead to see what, okay, yeah, that's what I thought, okay. Now, here's what we're going to do. I have my right triangle, my big right triangle here in blue. Here's my big right triangle, okay? And I drew an altitude from the right angle to the hypotenuse. That's a right angle also right there, okay? So having done that, I'm going to go ahead now and split these triangles up. So I have my big triangle here. Now please take some really good notes on this, students. That's triangle A, B, C. Got it? I'm going to draw my little triangle here. It looks like this, and then this, and then this. That's going to be triangle A. And I guess we better put a D right here. That's going to be triangle A, D, C. A, D, C. And we'll put a right angle right here, okay? And then we've got our other triangle up here. It looks like this. And if this is a right angle here, then we know we have a right angle here. So this angle right here is a right angle. And it's going to be triangle B, D, B, D, A. Alright? Now, all of these triangles, it says the two triangles formed are similar to the original and to each mark the congruent angles. Are you ready? Okay. We know the right angle is congruent to the right angle to the right angle. See this angle B right here? We know this gets 1 mark, right? And we know it shares angle B with this triangle here. Isn't that correct? Sure it is. Now look, if I've got a right angle here and 1 slash here, and a right angle here and 1 slash here, then it makes sense that this angle here has got to be congruent to this angle here. Remember guys, if triangles are similar, then all their angles are congruent. Now let's come over here. I've got angle C being shared with 2 triangles. See this angle C right here is also being shared. This angle C right here is being shared with my big triangle. It's also being shared with my little triangle. So if I have 2 marks here, I have 2 marks here. Now, I've only got 1 angle left here. This is 2 marks in the right angle. This is 2 marks in the right angle. The only thing left is 1 mark. So I'm going to put 1 mark here. Now why did I do that? Because I wanted you guys to quickly write a similarity statement. Okay? So I would say triangle A, B, C is similar to triangle. Okay, A's first, 90 degrees. So D would come first. B is second. B has 1 mark. So 1 mark. A comes next. So triangle DAC is similar to triangle. Okay, D came first. D's a right angle. So over here, D's a right angle. Next is A. A has 1 mark. B has 1 mark. So B. So triangle DBA. And now that you've done that, you can very easily write your proportions if I asked you to, like AB over DA. Or you could say DA over DB would be another ratio. I'm not going to write all those down, but my point is I wanted you to see how these triangles are similar. Okay, let's finish up lesson 9.1 quickly. Now, let's talk about the geometric mean of 2 numbers. You really need to know this. In fact, I believe we're not going to be able to finish up lesson 9.1. Yeah, this is a really long lesson. Now, 9.2 is very short. 9.3 is pretty short. And 9.4 is pretty short too. But we're not going to be able to finish up 9.1. But that's okay. I'm not worried about that. We're going to keep the video at a certain amount of time. But let's at least do this. Let's learn. Let's review how to find the geometric mean of 2 numbers, and then we'll call it quits, okay? No cheering allowed. Okay, if I asked you to find the arithmetic mean of these 2 numbers, you know how to find the arithmetic mean. You would add them together and then divide by what? There's 2 numbers, so you would divide it by 2. That's called the arithmetic mean, or the arithmetic average. Well, the geometric mean is different. The geometric mean simply means you put 1 number here, you put the other number down here, and then you put an x here and an x here, and then you solve for x. That's how you find the geometric mean. 2 times x is 20, x, or 2 times 10 is 20, x times x is x squared. Now take the square root of both sides, and you get this. That's the geometric mean. So the geometric mean of these 2 numbers is the square root of 20. Or another way to do it is simply do this. Another way is to take your 2 numbers, multiply them together, and take the square root of that number. So square root of 20. Either way, you get the same answer. Okay? Now, if you need to back this up and watch it again, do so, because tomorrow we're going to jump right into our review right here, and we're going to get into these really difficult theorems that deal with certain segments drawn in certain triangles and geometric means. You have to know how to find geometric means of 2 numbers, okay? You have to know this method here and this method here also, both of them. Alright? Okay. Hope this review video has been a help to you. If you have any questions, don't hesitate to call or email.